we're going to unpack a framework that tries to build our entire universe. I'm talking quarks, space-time, the whole shebang, out of just two simple building blocks. So, yeah, let's get into it. The whole motivation for an idea like this really kicks off with one powerful question. Think about it. Physics has gotten so complex, right? But what if? What if underneath all of that, the rules of reality are actually elegant and simple? What if it's all based on patterns and combinations, instead of this just ever-growing list of fundamental particles? And look, this isn't some new obsession. This quest it's ancient. It's got to be one of the oldest human endeavors, period. From the ancient Greeks all the way to physicists in labs today, we've always been driven by this deep, deep need to find the one, final, indivisible thing that makes up everything else. Just think about it for a second. What if the instruction manual for the cosmos wasn't just written in the cold, hard language of math, but also in the rich metaphorical language of ancient cosmology? Well, this explainer is all about a theory that says, yes, absolutely. It proposes a stunning connection between the tiny particles that make up you and me and the grand ways ancient thinkers saw the world. But before we can really appreciate this new perspective, we've got to understand the problem that modern physicists are wrestling with right now. And it all starts with our current picture of reality, which is, well, it's incredibly successful, but it's also just bafflingly complicated. For basically all of human history, we've been on this single obsessive quest. Find the smallest possible thing, the ultimate building block. We started out with the idea of the atom, this simple, elegant, indivisible unit. But the more we looked, the deeper the rabbit hole went. Protons, which we thought were fundamental, turned out to be made of even smaller things called quarks. Every time we thought we hit the bottom, we just found another basement level of complexity. And where has this quest led us? To a place physicists affectionately call the particle zoo. And it is a fitting name, believe me. We've discovered this dizzying, frankly overwhelming array of particles. We've got quarks with different flavors and colors. We've got leptons, bosons. It's a lot. And it's the sheer messy complexity that has everyone desperately searching for a simpler, more elegant explanation underneath it all. Now, our official guide to this zoo is the Standard Model of Particle Physics. And let's be clear, this thing is a masterpiece. It's probably the most successful scientific theory in history, making predictions that are accurate to an insane degree. But here's the catch. The Standard Model is a perfect description of how the universe works. It tells you exactly how all the animals in the zoo will interact. But it tells you absolutely nothing about why we have this specific zoo and not some other one. And that leaves us with these huge, nagging questions. Why are there exactly 3 families of particles? Not 1, not 5. Why 3? Where do their specific masses even come from? It all feels a bit arbitrary. And the biggest question of all, is there some simple, beautiful pattern hiding underneath all this mess? These are the cracks in our understanding where new ideas can start to grow.
And this is where things get really, really interesting. Instead of building an even bigger particle accelerator, what if we looked backward? This whole theory searches for clues in ancient philosophy. It proposes that the deep patterns of the universe might already be reflected in the deep patterns of human thought.
So our first stop is ancient Greece. They gave us this powerful toolkit for thinking about reality. And you'll see, they were grappling with the exact same big questions we are today. They were just using philosophy instead of particle colliders.
Just think about the philosopher Democritus. We're talking over 2,000 years ago. He proposed that everything is made of these tiny, indivisible units he called atoms, and that all of reality was just these atoms bouncing around and interacting. Sound familiar? It's basically the direct philosophical ancestor to our modern search for elementary particles.
Now, this leads to a classic debate between Plato and his student, Aristotle. Plato believed that true reality was this perfect, unchanging realm of forms that existed somewhere else, and our world was just a shadow of that. But Aristotle, he disagreed. He argued the form, or the essence of a thing, wasn't in some other dimension, it was immanent, meaning it exists right here, inside the object itself. Now remember this tension, this pull between a perfect idea and its physical copy, because it's a huge clue for later.
So the Greeks gave us atoms and forms. For our next set of clues, we're going to turn to Hindu cosmology, which offers this absolutely incredible detailed description of how our entire universe could unfold from a single point of unity.
At the heart of this cosmology are what are known as the three gunas. You can think of them as these three fundamental cosmic forces. There's sattva, which represents wholeness and balance. Then you have rajas, the principle of action, energy, and change. And finally, tamas, which stands for inertia and darkness. According to this tradition, literally everything in the universe is just a different combination of these three forces.
Now these three gunas, they don't just sit still. They drive a process called the Brahma Chakra, or the cycle of creation. It's essentially the story of how a single, unified consciousness becomes the diverse, manifested universe we see all around us. It's a journey from one to many, all driven by the interplay of sattva, rajas, and tamas.
Okay, so we've got Greek ideas about form and matter and Hindu ideas about cosmic forces. So, how on earth do you connect this stuff to particle physics? Well, the answer's kind of brilliant. You translate these philosophical concepts into the language of mathematics, specifically something called combinatorics.
This right here is the magic trick. The three gunas are mapped directly onto three mathematical variables. Sattva, or wholeness, becomes S, representing the total number of combinations, like counting whole clouds in the sky. Rajas, the principle of action, becomes R, the number of elements in any one combination, like counting individual raindrops. And tamas, or inertia, becomes T, the total number of original elements you started with, like counting scattered hailstones.
And just like that, ancient philosophy becomes a formula. These deep qualities of cosmic creation, sattva, rajas, and tamas, are now the variables S, R, and T in a mathematical equation that can describe how sets of things can be combined. The abstract suddenly becomes totally calculable.
So now we can visualize the Brahma Chakra as a mathematical process. You can see it here as this cascade, moving from a single, unified set at the very top, where everything is one, and flowing down through all these increasing levels of complexity and diversity, all the way to individual elements at the bottom. The cycle of creation is literally reimagined as a sequence of combinations.
All right, let's put it all together now. Let's walk through the entire cosmological story this model tells, a story that begins with pure abstract unity and somehow ends with the physical universe.
So, what this model is describing is a process called involution. And hey, remember how we talked about Plato's perfect idea and Aristotle's tangible forms? Well, this is that concept in motion. It's a journey where a single perfect idea cascades downward, unfolding into the many distinct physical things we see all around us.
We can break this whole journey down into 4 key steps. It starts with step 1, pure unity. This is the perfect Platonic idea of the universe. Then comes step 2, differentiation, where that single idea fractures into countless combinations. In step 3, we get the final forms, where the essence of things becomes tangible and real, just like Aristotle described. And all of that brings us to the final explosive moment, step 4. At the very, very end of this entire cascade is one final singular state. It represents pure potential. And according to this framework, this state, imitating emptiness, is the precursor to the Big Bang. It's the moment where the potential of all those philosophical and mathematical steps finally erupts into the observable physical universe.
And that leaves us with a pretty fascinating final thought. This whole theory bridges millennia of human thinking, from ancient philosophy all the way to modern math. And it forces us to ask, is physics discovering brand new truths about the universe, or is it just creating a new language to tell a very, very old story?